Fourier series is a mathematical tool that breaks down any complex repeating wave into a sum of simple, smooth sine and cosine waves of different frequencies. So for the task 1, we are going to convert the function fx to a Fourier series. And as for the question 1, here we have a piecewise function, where the first function is negative 2x with interval of negative 1 until 0. And for the second function is exponential to the power of x minus 1 with interval of 0 to 1. So here we are going to sketch the function, and we get first is the linear line, which is a straight line, and also we got the exponential curve. So when we convert it to the silver period, it shows how the V-like pattern repeats every two units along the x-axis to create the wave shown in the second graph of the image. Next, let's move on to the B, which is to determine the Fourier series of fx. So Fourier series of fx is defined as fx equals to a naught over 2 plus summation of an cos n pi x over l plus bn sin n pi x over l. So firstly, we are going to find our l first. So the given period is 2l is equal to 2, and our l will be close to 1. So we are going to find the a naught, an, and bn. So firstly, we will find our a naught, and we got the a naught is equals to exponent minus 1. So next we will find our an. So to find an, our formula will be 1 over l, where our l is 1, and integration of fx cos n pi x over 1 dx. So our fx is actually the piecewise function that from the question. So we just insert the function into the formula. So we will get negative 2x cos n pi x dx, and also exponential to the power of x minus 1 times cos n pi x dx. And then we will find the value, we will find the value of the minus 2x cos n pi x dx by using the tubular method. And next, for the exponential of x times cos n pi x dx, also we will use the tubular method to solve the equation. And lastly, for the cos n pi x dx itself, we will use the normal integration to find the value. And lastly, we will combine all three equations into one, and then we will get the complete value of an. So next, we are going to find our bn. So how to find the bn? Our formula will be 1 over l, where our l is 1, times integration of fx sin n pi x over 1 dx. So actually, to find bn an is actually same, but the difference is an we will use cos, and for bn we will use sines. So for the fx, we will take from our piecewise function from the question, and then we will insert it to the formula. And as usual, we will using the tubular method to find the value for the minus 2x sin n pi x dx, and also for the exponential of x sin n pi x dx. And for the sin n pi x dx, we will use the common or basic integration to find the value, and we will combine all those three equations into one, and we will get the complete value of bn. So lastly, after we complete finding our a naught, an, and bn, we will convert, or we will insert the each value to the Fourier series of fx. So we will enter the a naught, an, bn into the formula, and we will get the perfect series or perfect Fourier series of the fx. So now let's move on to the next question, which is question 2. So here we have a piecewise function of fx with function of minus pi square plus x square with the interval of minus y to 0. And then we have a second function, it is pi square minus x square with interval of 0 to pi. So for a, we will sketch the function of fx, and then after we sketch it, we can see that it's look like an half-range Fourier sine series. So next for B is to determine the Fourier series of fx. So given period is 2l equals to 2 pi. So our l will be equals to pi. Therefore, our fx will be a naught over 2 plus summation of an cos n pi x over pi, since our l is pi, plus bn sin n pi x over pi. So our fx will become a naught over 2 plus summation of an cos n x plus bn sin n x. So the first step we are going to do is to classify the type of the function. For this, our function is full range Fourier series, but for this we are going to classify our type of function first, and here we get that the function is odd. Therefore, our a naught, an will be equals to 0. Then the half-range Fourier sine series for fx will be summation of bn sin n x. So since our a naught and an is equal to 0, so here we will only need to find our bn only. So for bn, for half-range Fourier series, the formula is a bit different. Before this, we will use 1 over l, but for half-range, we will use 2 over l. So the formula is 2 over l, integration of fx sin n pi x over l dx, where our l is pi, and our fx is our piecewise function from the question. So we just need to insert the function into the formula, and therefore we will get the 2 over pi times with the integration of pi square sin n pi x dx minus integration of x square sin n x dx. So here we are going to use the tubular method to find the value of the x square sin n x dx. And also next, for the pi square sin n x dx, we'll use the basic integration to find the value. So after we get all the value, we are going to insert it back to our original formula to find the complete value of Bn. And therefore, after we find the Bn, we will insert the Bn value into the Fourier series of fx to complete our Fourier series function to find the fx. So lastly is for question 3, which is the last question for the task 1. We have a function of fx which equals to x squared with interval of -1 to 1. So for question A, to sketch the function, here we can see it create curved line because this is actually the quadratic equation, and for several period we can see it repeatedly for every 2 units and create a wavy line. So for B, we are going to determine the Fourier series of fx. So given period is 2l equals to 2, so our L will be equal to 1. Therefore, for our fx is going to be a0 over 2 plus summation of an cos n pi x plus bn sin n pi x. So first thing first we are going to do is to classify the type of function to determine whether it is even and odd. And here we can see that our function is even, therefore our bn value will be equal to 0. Then this function is actually the half-range Fourier cosine series. And for the formula of the half-range Fourier cosine series will be fx equals to a0 over 2 plus summation of an cos n pi x. So we are going to find the a0 and an value. So for a0, get the value is 2 over 3. Meanwhile, for an, we will use the tubular method to find the value of the x squared cos n pi x dx. And here we get the answer for the an. So after we have find our a0 and an, we are going to insert the value into the Fourier series of fx to find the complete fx equation. So here is our Fourier series of fx.
Okay, next is task 2, given fx. So expand the function by sketching function fx using mathematical application like GeoGebra or anything else for interval from -4 to 4. And it is also asks us to determine the expansion Fourier series in cosine and sine series. So this is the graph for cosine series, interval from -4 to 4. So this is the formula or equation for half-range Fourier cosine series, which is fx equal a0 over 2 plus sum of an cos n pi x over l from n equal 1 to infinity, where all the unknowns like l is equal to 4, a0, the formula is given equal to 2 over l, integration from 0 to l fx dx, an equal to 2 over l, integration 0 to l, fx cos n pi x over l dx, and for Fourier cosine series, the bn equal to 0. The first step is to find the a0, which is, we know that the formula for a0 is 2 over l, integration from 0 to l, fx dx. So after we substitute every unknown and every variable into the equation, we can get the equation is equal to 2 over 4, integration 0 to 2, 4 dx plus integration 2 to 4, x minus 4 square dx. So we can direct integration for both of these, and then we get for a0 is equal to 16 over 3. The second step is to find the an. After we substitute all of the unknown and variable, we can get the formula for an is 2 over 4, integration from 0 to 2, 4 cos n pi x over 4 dx, plus integration from 2 to 4, x minus 4 square cos n pi x over 4 dx. So we can divide this into two parts. The first part is integration from 0 to 2, 4 cos n pi x over 4 dx, and the second part is integration from 2 to 4, x minus 4 square cos n pi x over 4 dx. So by integrating the first part, which is integration from 0 to 2, 4 cos n pi x over 4 dx, we can get the answer is actually equal to 16 over n pi sin n pi over 2. So integrating the second part, since the second part of the integration consists of algebraic function and trigonometric function, so we can use the tabular method in order to find the answer for integration 2 to 4, x minus 4 square cos n pi x over 4 dx. And after we use the tabular method, and then we get the equation, the answer is negative 16 over n pi sin n pi over 2 plus 64 over n square pi square cos n pi over 2 plus 128 over n cube pi cube sin n pi over 2. So in order to determine the an, we combine the first part and the second part into the an general equation. So we can get the an is equal to 32 over n square pi square cos n pi over 2 plus 64 over n cube pi cube sin n pi over 2. And then we substitute the value into the half-range cosine series, and then we get fx equal 8 over 3 plus sum of 32 over n square pi square cos n pi over 2 plus 64 n cube pi cube sin n pi over 2 cos n pi x over 4. So the first one is the graph for the sine series. This is the graph for sine series, interval from -4 to 4. So this is the formula or equation for the question B, which is Fourier sine series. The equation for fx is equal to sum of bn sin n pi x over l, where l is equal to 4, as we mentioned before. A0 and an is equal to 0, and the bn equation is equal to 2 over l, integration from 0 to l, fx sin n pi x over l. So the first step is to find the bn. So after we substitute every value into the bn equation, we can get 1 over 2 in bracket integration from 0 to 2, 4 sin n pi x over 4 dx plus integration 2 to 4 x minus 4 square sin n pi dx, n pi x over 4 dx. So we can divide this into two parts, which is the first one is integration from 0 to 2, and the second one is integration from 2 to 4. So integrating the first part of integration of 0 to 2 for sin and pi x over 4 dx. So due to 4 is constant, we can cancel out we can take out the 4 into from the integration, and we left with the 4 integration 0 to 2 sin and pi x over 4 dx. We can direct integrate this and get the answer is equal to negative 16 over n pi cos n pi over 2 plus 16 over n pi. So integrating the second part by using tabular method, since the integration consists of algebraic function and trigonometric function. So after we integrate them by using tabular method and substitute the 4 and 2 into the equation, so we left with 128 n cube pi cube cos n pi plus 16 over n pi cos n pi over 2 plus 64 over n square pi square sin n pi over 2 minus 128 n cube pi cube cos n pi over 2. After combining the first part and second part, therefore we get the Bn is equal to 8 over n pi plus 32 over n square pi square sin n pi over 2 plus 64 over n cube pi cube in bracket cos n pi minus cos n pi over 2. So lastly, we substitute the value of Bn into half range sine series, which is fx equal sum of Bn sin n pi x over L, and then we get fx equal to sum of 8 over n pi plus 32 over n square pi square sin n pi over 2 plus 64 n cube pi cube in bracket cos n pi minus cos n pi over 2 sin n pi x over 4. Lastly, for task 3, the question asks us to find any function fx of H60 and function values over one cycle as shown in the table below, and find the Fourier series expansion up to third harmonic and give your answer in standard form. All calculation must be corrected to 2 decimal places. This is the formula or equation for task 3 in order to complete task 3 harmonics analysis. So we get the n naught equal to 1 over 6 sum of fxr, n equal to 1 over 6 sum of fxr cos nxr, bn is equal to 1 over 6 sum of fxr sin nxr, c naught is equal to 1 over 2 n naught, cn is equal to square root of an square plus bn square, and lastly is alpha n is equal to tangent inverse an over bn. Next, this is the summary table of the harmonic analysis in order to find the n naught, an, and bn. So based on the previous table, we can calculate the a naught and c naught is equal to a naught is equal to 1 over 6 times 6.2 is equal to 1.03, c naught is equal 1 over 2 times 1.03 is equal to 0.52. So in order to calculate the first harmonic, we can use the equation previous equation. Thus we substitute the value into the equation. So for a1 is equal to 0.20, b1 is equal to 0.19, c1 is equal to 0.28, and alpha 1 is equal to 46.47 degree angle. Next calculating the second harmonic, same as before for first harmonic. So we get the A2 is equal to negative 2.07, B2 is equal to negative 1.18, C2 is equal to 2.38, and alpha 2 is equal to 60.31 degree angle. But since A2 and B2 are negative, which means it is in a quadrantry, so we need to add 180 degree is equal. So lastly, alpha 2 is equal to 240.31 degree angle. And for the last harmonic, which is the third harmonic as the question mentioned, A3 is equal to negative 0.53, B3 is equal to 0.40, C3 is equal to 0.67, and alpha 3 is equal to negative 52.96 degree angle. Since A3 is negative and B3 is positive, which means this harmonic is in quadrant 2. So we also need to add 180 degree into the alpha 3 answer, and then we get the answer for alpha 3 is equal to 127.04 degree angle. So after we calculate the first, second, and third harmonic, we can substitute every value into the standard form as below. So fx equal to c naught plus c1 sine in bracket x plus alpha 1 plus c2 sine in bracket 2x plus alpha 2 and plus c3 sine in bracket 3x plus alpha 3. So after we substitute every value into the equation, the final answer for this equation is fx equal to 0.52 plus 0.28 sine x plus 46.47 degree angle plus 2.38 sine 2x plus 240.31 degree angle plus 0.67 sine 3x plus 127.04 degree angle.